Welcome to G Fun Facts Online, the podcast that dives deep into the fascinating and sometimes surprising stories our world has to offer. Today, we're tackling a really big one, something that affects every living creature on this planet, including us. We all know our Earth's climate is changing, but what happens when the homes of animals start to disappear, when they can't adapt or move fast enough? We're going to explore a cutting-edge and sometimes controversial solution: moving animals to new homes, all guided by powerful data. Sounds like sci-fi? Stick around, because it's happening right now. So why are we even talking about picking up animals and moving them? Well, imagine your neighborhood slowly becoming unlivable. That's what climate change is doing to countless animal habitats. Temperatures are rising, rainfall patterns are going haywire, extreme weather is becoming the norm, and sea levels are creeping up. For many species, their ancestral homes are literally vanishing or becoming toxic. They simply can't keep up. Traditional conservation efforts, like setting up protected parks, are vital, but what if those parks themselves change beyond recognition? We've already seen heartbreaking examples, like the bramble K. melames, a little rodent that became the first mammal confirmed to go extinct due to human-caused climate change. Its tiny island home was swallowed by the sea. This harsh reality is forcing scientists to think outside the box, to consider strategies like species relocation, not as a first choice, but as a critical lifeline in an increasingly desperate situation. Now, moving animals isn't as simple as catching them and dropping them off somewhere new. It's incredibly complex, and there are huge risks. But this is where things get really interesting, and where G Fun Facts Online loves to explore. We're seeing an explosion in data and technology that's transforming how these decisions are made. Think data science, artificial intelligence, AI, and machine learning, ML. These aren't just buzzwords. They're becoming conservation's newest superheroes. So how does it work? First up, there is predictive habitat modeling. Scientists use super smart computer models, called species distribution models, or SDMs. They feed these models tons of information: where species live now, details about their environment like temperature and rainfall, and, crucially, climate change predictions. The models then crunch all this data to identify climate refugia. These are areas that could become suitable new homes for species in the future, even as their current ones fail. Machine learning algorithms, like one called random forest, are proving incredibly good at finding these future safe havens. Then there's genetic insights for resilience. It's not just about finding a new place, but also choosing the right individuals to move. Genetics helps us understand a species' ability to adapt. By looking at their DNA, scientists can find individuals with traits like heat tolerance or disease resistance, making them better candidates for thriving in a new, challenging environment. It's like picking the toughest members of the team for the most difficult mission. This also helps avoid genetic problems down the line. And of course, there's ecosystem and risk analysis. You can't just introduce a new species without thinking about the neighbors. Data helps scientists assess the potential impact on the new ecosystem. Will the newcomers become invasive? Will they outcompete native animals or plants? Will they bring new diseases? These are critical questions that data helps answer before any move is made. Finally, imagine trying to process information from satellites, remote sensors, citizen scientist reports, and genetic sequences all at once. It's a data tsunami. This is where AI and big data integration come in. I can sift through these massive datasets, spot patterns, and make predictions that would be impossible for humans alone. It's like having a super intelligent assistant dedicated to saving species. With all this data power, conservationists are developing some really targeted strategies. They're identifying those future safe havens, the climate refugia. Sometimes, instead of moving whole populations, they might use assisted gene flow, which means moving specific individuals with beneficial genes to help existing populations adapt. In sad cases where a species is already extinct in an area, data can help find a suitable ecological replacement, a similar species that can perform the same jobs in the ecosystem. And crucially, data helps prioritize which species are most vulnerable and need these urgent interventions the most. But let's be real, this isn't a walk in the park. Species relocation is packed with challenges and big ethical questions. There's always the ecological risk. What if the relocated species does more harm than good in its new home? What if it becomes invasive? Genetic uncertainties remain, despite our best efforts. And practically speaking, Moving animals, especially large numbers of them, is incredibly expensive and logistically a nightmare. Then there are the ethical dilemmas. Are we playing God by moving species around? What are our responsibilities to individual animals versus entire species? And despite all the amazing models, there's always a degree of uncertainty. Climate projections aren't crystal balls. We also have to consider the human side, public opinion, getting local communities on board, and navigating complex legal rules. This brings us to a vital point. This kind of massive undertaking can't just be about scientists and data. It needs collaboration, a real team effort. And a crucial part of that team is local and indigenous communities. Indigenous peoples often have generations of knowledge about the land, wildlife, and sustainable living. This traditional ecological knowledge is incredibly valuable. Integrating it with scientific data can lead to much better, more respectful, and ultimately more successful conservation. It's about recognizing that these communities are often the frontline stewards of biodiversity. So, species relocation, supercharged by data, is becoming a really important tool in our fight to protect wildlife from climate change. But it's not a magic fix on its own. It has to be part of a bigger picture. That means still working hard to protect and restore existing habitats, making sure animals can move naturally between areas, and, this is the big one, drastically cutting greenhouse gas emissions to slow down climate change in the first place. And for every relocation project, something called adaptive management is key. It means setting goals, taking action, carefully watching what happens, and then tweaking the plan based on what's learned. It's a cycle of learning and improving because we're dealing with complex, changing systems. Constant monitoring after animals are released is absolutely critical to see if they're thriving and what their impact is on their new neighborhood. The climate crisis is pushing us into uncharted territory in conservation. Species relocation, powered by incredible advances in data analysis, AI, and genetics, is no longer a fringe idea but a serious strategy being explored and implemented. It's a testament to human ingenuity, but it also comes with huge responsibilities. The challenges are immense, and the ethical questions are profound. But the alternative, watching species vanish because we couldn't or wouldn't act, is far starker. By carefully using data, working together, and always being ready to learn and adapt, data-driven species relocation offers a genuine glimmer of hope for wildlife on our rapidly changing planet. It's a new era of conservation, one where we have to be more proactive, more informed, and more thoughtful than ever before. Thanks for tuning in to Fun Facts Online today. We hope this has given you a lot to think about. What are your thoughts on species relocation? Join the conversation online. Until next time, stay curious.